Hello, welcome back to Algebra. The title of this lesson is called Complex Fractions. This is part one. There's actually going to be three parts to this lesson. So what we'll do in this lesson is we'll talk about what is a complex fraction, and we're going to spend the entire time learning how to simplify these things. In fact, I don't really like the sound of this title. It sounds really difficult, it sounds really hard, but what we're going to do is work through some easy examples into some medium example territory, and then what you're going to end up finding is that even though the problems at the end of this lesson look really, really hard, once we build our skills, they'll require a lot of work, okay? I'm not going to lie to you, but they're not going to be difficult for you to understand what to do. And then when you get on into the next couple of lessons, those problems will look terrifying to someone who hasn't done this with me, but I'm going to work you up in skill level so that they won't seem that difficult either. In fact, if I had to rename this, typical textbook name is called complex fractions. If I had to rename it, I would call it simplifying really ugly looking expressions in algebra involving ugly looking fractions. That's what I would call it. So in order to do this, you have to be able to manipulate fractions. There's really no way around it, and that's why I spent a lot of time reviewing fractions with you. If you have no idea how to divide fractions in algebra, then go back and watch some of those more basic lessons on how to do basic fraction manipulation and come back and meet me here. All right, so let's just jump into the first one and see what a complex fraction in algebra looks like. You might have something like this, 1 minus 1/3. Doesn't look so bad, right? But then we'll take that and we'll put that whole thing in a numerator of a much larger fraction. And on the bottom, it'll be 1/2 minus 1/6. So you see what we have going on here. You have some kind of fraction manipulation in the numerator, and then you have some separate fraction manipulation in the denominator, and then that whole thing is a fraction. So this is probably the simplest complex fraction I can give you, but just keep in mind the complexity level will ramp up. So if you understand how to do this, that's awesome. Just keep on going with me, because by the end of the lesson, and definitely into the next couple of lessons, there will be some truly gargantuan expressions that you will be very comfortable understanding how to tackle. So what do we do here? We have to take the numerator separately from the denominator. So if all you were given was this, you have to understand how to handle that. Now you can't subtract 1 minus 1/3 unless you have a common denominator. So we can always write the number 1 as 5 over 5, 2 over 2, 10 over 10. We can always do that. But in this case, since the denominator is 3, we want to write it as 3 over 3 because that's equal to 1. So the numerator is equal to 3 over 3 minus 1/3. Now we're going to do the subtraction in the next step. The next thing I want to point out to you here is the way I am solving these problems is exactly the way I want you to solve the problems. I'm not babying it down for you. A lot of people will try to do this in their head and get the right answer most of the time, but what will happen is by the end of this lesson, the problems will be so hard, you won't be able to do it in your head, no matter how good you are. So write it down. We will do the subtraction in the next step. Right now, we're just getting a common denominator. Now we'll do the rest of it later. How do we handle the bottom? Obviously it's not quite so easy as the top, but we see we have a 6 and we see we have a 2. I know that 2 times 3 is 6, so I'm going to manipulate this first fraction. I'm going to make a larger fraction here, the 1/2, or a larger bar here. I'm going to leave the 1/6 alone because I know that I can multiply this first fraction by 3 to give me a common denominator of 6, and if I do that, I have to multiply the top by 3 as well. So then what I will have on the top, now I can go ahead and do some, you know what, let's go ahead and not manipulate the top just yet. Let's wait. Let's make it 3 over 3 minus 1/3. On the bottom, what do we have? You multiply, you get a 3 over 6 minus 1/6. So now we can subtract the top fraction, we can subtract the bottom fractions, and then we'll handle the overall division of those two things later. So in the top, the common denominator is a 3. So that's going to be the denominator of our answer. And it's going to be 3 minus 1. So 3 minus 1 is 2. And then on the bottom, the denominator is 6. And you have 3 minus 1, which is also 2. So what you have is 2/3 over 2/6. So it looks ugly, but really it's just a number divided by another number. And you know that when you have a fraction or any kind of division, you can take and change this into multiplication. That's the way you handle fractions. Like any fraction divided by any other fraction, you do it as follows. You say 2/3, that's the top number, change the division to multiplication, and then when you do that, you have to flip the bottom upside down, 6 over 2. So you change this to multiplication, take the bottom one, flip it upside down, and now you can go ahead and get the final answer. Now I can go ahead and multiply it out, but typically what I want to do, let me rewrite it one more time, 2/3 times 6/2. before we do the multiplication, typically what we want to do is see if we can cross-simplify anything first. In this case, the numbers are so small it won't matter. But we see we have a 2 and a 2, so I can say 2 divided by 2 is 1, 2 divided by 2 is 1. Basically, I'm dividing the top and the bottom by the same number 2, striking it out. And then I also see I have a 3. And I have a 6, so I can divide both by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So I divided both of these numbers by 2, give me 1, so it disappears. I divided both of these numbers by 3. That divided by 3 is 1, that divided by 3 is 2. So the final answer is just going to be, this is an implied 1 times 2 is 2. This is an implied 1 times 1 is 1, so 2 over 1, so the answer that you actually get is 2. And that's the final answer. Now I've gone through a lot of excruciating detail here with some small numbers, mostly because I want you to get back in the habit of thinking about fractions. Because in a few minutes, we will have problems that will be much more complicated than this, but the same steps will apply. That's why I'm doing an easier problem first. You tackle the numerator first. You get a common denominator, whatever means necessary to get a common denominator so that you can do the subtraction. Separately from that, you work in the denominator, whatever means necessary to get a common denominator. In this case, we chose 6. So that I could then subtract the denominator fractions. I do the subtraction, and then I have a fraction divided by a fraction. So anytime we divide fractions, we change it to multiplication, but then we have to flip the bottom over. Now at this step, I did cross simplification, but just notice 2 times 6 is 12, 3 times 2 is 6, so it's 12 divided by 6, 12 sixths. If you divide 12 divided by 6, you're going to get 2. So if I didn't do this simplification here, I would get 12 divided by 6 is 2, I would get the right answer. But I'm showing you that we typically cross-simplify because when the fractions get more complicated, it's really cumbersome to just do the multiplication and simplification. It's much easier to kind of simplify before we do the multiplication. So again, fraction manipulation is absolutely crucial. Now the roadmap here, we're going to do these complex fractions simplification, right? They're going to get harder and harder and harder. And then the next batch of lessons after these will be solving equations that contain these really complicated looking fractional expressions. So we're getting the practice with the simplification, but in the back of your mind, just keep in mind that we're going to be solving equations that involve these large expressions. So don't skip over this stuff. It's not going to go away. It's not going to disappear. We're going to be using it, unfortunately, or however you want to look at it. The good news is, when I continue to work a lot of problems with you, it will become much, much easier, and they will become at least a little bit fun, I think, because as fun as this kind of stuff can be, to be honest with you. So let's take a look at the next one. Again, basically the same complexity level, 1 minus 4/5. In the denominator of that large fraction, let's do 1/4 minus 1/5. Same strategy. Deal with the top separately from dealing with the bottom. Once we get that manipulated down, then we'll do the fraction division. So here again, we have a 1. We need a common denominator of 5. So what we will do is write the 1 as 5 over 5, minus 4/5. Okay, that works great. In the bottom, now this one's a little bit harder because before we had a 2 and a 6. So we knew that 2 times 3 is 6. So all we had to do was manipulate this to get a common denominator. But this is harder because we can't multiply this to get 5 and we can't multiply this to get 4. So we look at 4 and 5, and you can choose any common denominator you want. The first thing that pops in my mind is the number 20, because I know that 4 times 5 is 20, and I know that 5 times 4 is also 20. So what I'll do is I will take the first fraction, 1/4, and the second fraction, 1/5, and I will say, well, let me multiply this one by 5. I got to do it to the top and the bottom. That'll make 20. And then I'll multiply this one by 4, but I have to do it to the top and bottom, and that will make a 20 of a common denominator. Now I'm using a common denominator of 20 because it's the thing that popped in my mind, but you can use lots and lots of numbers for the common denominator. It doesn't have to be 20, just something that can be, that 4 can multiply to give me that, and that 5 can also multiply and give me that. So for instance, 40 would work also, because 4 times 10 is 40, and then 5 times 8 is also 40. So I could use 40 as a common denominator. I can use lots of things as a common denominator, but the smallest one that I'm going to choose is what I have on the board here. Now on the top, we have a common denominator, so we just subtract 5 minus 4 is 1. The common denominator was 5. And in the bottom, what we're going to have, this will be 5/20ths. 5/20ths, subtracting 4/20ths. 4/20ths. In the next step, let's go ahead and do the subtraction. So on the top, we have 1/5. On the bottom, we have 5 minus 4 is 1, and the common denominator was 20ths. So it would be 1/5 divided by 1/20. So then we take this fraction division, we change it to multiplication. So we have the 1/5, we change it to multiplication. This, we flip it over to become 20 divided by 1. Now, as I said in the last section, we could multiply this. 1 times 20 is 20. 5 times 1 is 5. So it would be 20 over 5. 20 over 5 is 4. You just divide 20 divided by 5. So we know the answer is 4. But typically, when the problems get more complicated, we want to cross-simplify first. So let me rewrite it again. 1/5, 20 over 1. So we'll just get practice for that. We say, well, we have a 5 and we have a 20. We know we can simplify. 5 divided by 5 is 1. 20 divided by 5 is 4. And now what I'm presented with is 1 times 4 on the top, and then implied 1 times 1 means 4 over 1, which is 4. That's exactly what we said we would get. 1 times 20 is 20, 5 times 1 is 5, 20 divided by 5 is 4. So whether or not you cross-simplify first, or you just multiply and simplify at the end, you get the same answer. But as we get into the more complicated expressions, you're definitely going to want to do the cross-simplifying ahead of time, so that's why I'm showing you this. So the first two problems, I don't want to say it in a kind of a weird way. They're kind of baby problems. I mean, they're not easiest thing in the world, but they're very simple conceptually to understand. Now, what we're going to do is we're going to take the training wheels off and we're going to get into some slightly more medium level problems with complex fractions. But you'll find out that they're all totally manageable. Next problem, x plus the number 1, that's the numerator. The denominator is 1 plus 1 over x. Now, when a student sees a problem like this, they generally have some idea what to do. Work with the top, work because it has numbers. Work with the bottom, divide, and all that. But when a student sees a problem like this, a lot of times their brain just freezes and explodes and they have no idea what to do. You have to pretend those x's are just numbers. You don't know what the number is, but it is a number. So you treat the fraction manipulation the same way. There are no new rules for this problem. So what do we do with the top? The top is x plus 1. We cannot really add them, and there's no fraction, so we just leave it alone, x plus 1. I don't know, I can't add them, so I just leave them alone. The bottom has 1 plus 1 over x, but the bottom of this fraction is x. Remember how we did this one. The bottom of this fraction here, or the top here, is 1 minus this. So the bottom was a 5, so we chose 5 over 5 to get a common denominator. Basically, in order to add this here, I have to have a common denominator of x. See, normally the denominator has numbers, so you know to look for that. But in this case, the denominator of that fraction is the variable x. So I have to have a common denominator with x in it in order to even add or subtract those fractions. Same rule applies. So how do I do it? Well, this number 1, I'll change it to be x over x, the same way we did it with the numbers. We had 5 over 5, and we did 3 over 3, I think. So we'll make this x over x plus 1 over x, because this is exactly the same as this. I haven't changed anything, but now I have a common denominator. So the numerator stays the same, and the denominator is, over here and here, the common denominator is x. But the numerator is x plus 1, which, again, we can't really add, so we just leave it as x plus 1. And then this fraction bar has to extend here. So what we have in the numerator is x plus 1, and the denominator of the larger fraction bar is another fraction, which is x plus 1 over x. It looks like a nightmare, right? But then you say, well, okay, how did we do it before? We said we have something divided by something. We change this fraction division to multiplication. So what we will then have, we take the numerator, which is x plus 1. We take this fraction division and change it to multiplication. We take the bottom fraction, we have to flip it upside down, just like for the cases before with numbers, x plus 1. And then don't forget that this x plus 1 on the top can always be written as a fraction of x plus 1 over 1. In other words, the numerator is x plus 1, but anything can be written as itself divided by 1, right? So we'll take the numerator as the numerator over 1 times the flipped over version of the denominator. Now let me rewrite it. X plus 1 over 1 times x over x plus 1. Now here's the deal. This is why I kind of went on and on about you want to cross simplify first. Because what you could do is you could multiply this stuff out and then multiply this stuff out, but then you'd have to cancel a bunch of stuff. You'd have to factor and stuff to cancel. Or you could just recognize, well, hey, this numerator here, I can have an implied parentheses around it, is exactly the same, so I can strike through it. Divide by x plus 1, divide by x plus 1. In other words, look for common terms in the top and the bottom. They're gone. they don't disappear to 0. There's an implied 1 here, and there's an implied 1 here because you've divided them away. And so all you really have left is x times the implied 1 times the implied 1, and anything divided by 1 is just itself. So the answer is x. And that's the final answer. So if I had started out with a problem like this, most people would still get it, I think. But it's significantly harder to wrap your brain around because before you deal with these kinds of complex fractions, see why they're called complex fractions now, because they're ugly. Nobody wants to deal with that stuff, right? But when we take a step back and look at what it looks like with numbers and get our brain wrapped around it, then we can transition to this and it makes a whole lot more sense. So now that we have our feet wet, for lack of a better word, let's take the training wheels off a little bit more and jump into something a little more complicated. But again, we will be able to get through it because now we built our skills up. We have a minus b over a to the negative 1 power minus b to the negative 1 power. And all of that is in the denominator of this fraction. So now not only do we have a weird looking fraction, but what's in the bottom involves negative exponents. So a lot of students will start to say, well, I'm going to try to add these, I'm going to try to factor something, I'm going to try to cancel the a's or something like that. Instead of just stepping back and saying, what can I do? What is legal? What have I done with negative exponents before? If you remember back, we talked about negative exponents. I said you always write negative exponents, or you can write negative exponents, as 1 over. Basically, you move it downstairs and make it a positive exponent. So in the next step, instead of guessing, do what you know to be true. You cannot subtract a minus b, so you have to leave that alone. But in the bottom, this a to the negative 1 power becomes 1 over a. It's 1 over a to the first power, but that's an implied 1, so I'll leave it alone. The minus sign comes along, and this becomes 1 over b to the first power. All of this was learned back in the lesson on negative exponents, so if you don't remember that, you got to go back to that. Like, learning algebra is like building a house. You have to build a foundation, then you have to put the bricks, then you have to put the roof, and all of that. But if you're trying to build a roof and there's no foundation, then the house falls down. You can't do it. So that's why we learn these things in sequence, and I give lots of practice. So here we have negative exponents. That's a previous skill. Now we have those negative exponents written as fractions. Now we have to deal with the fractions, just like we had to deal with the fraction here. So the numerator we can't do anything with. A minus b, we have to leave that alone. But I have to get a common denominator here. So what I'm going to do is say, well, let me write 1 minus a minus 1 minus b, and I need to figure out what can I multiply this and this by to give me a common denominator. Well, the only thing that's really, I shouldn't say the only thing, the easiest thing that's going to work when there's nothing obvious is just to take the first fraction and multiply it by whatever the other denominator is. That will give me a denominator of ab. Then if I take this one and multiply by what the other one is, in this case a, then I'll have a denominator here of, well, it's written as b times a, but you know you can flip it around to ab. So because I've multiplied this cleverly and I've multiplied this cleverly, when I do it, I'm going to have the common denominator will be ab. See, this is where a lot of students get crazy tripped up because they understand the numbers. They understand how to get 5 as a common denominator. But when it comes to variables, all that matters is the denominators have to match. Exactly. The exponents, the variable names, everything has to match. So I just choose to make the denominator a times b because that's the easiest thing to be able to get both of them into that form. There are other denominators I could choose. I'm not going to get into it. But this one works just as well, so we'll use that. So in the numerator, we're going to have a minus b. And in the denominator, what are we going to have? This will be b over ab minus a over, again, it's ba, but you can flip that around to ab because it doesn't matter the order in which you multiply things. So in the top, again, we'll carry this through. The a minus b comes along for the ride. And here we have a common denominator, ab. So that'll be our new denominator. Just like if our common denominator is 4, we just carry that into the answer. Then the numerator becomes b minus a. b minus a, just like this. So see what we have is we have very similarly to what we had up here in this step, we had something divided by a fraction. Here we have something divided by a fraction. How do we handle it? We change this division to multiplication. So what we have is you're going to have a minus b. You're going to change this division into multiplication, because really this a minus b is an implied a minus b over 1. You can think of this numerator as just being a minus b over 1. It's a fraction, because the number 10 can be written as 10 over 1. The number negative 17 can be written as negative 17 over 1. So we just say the numerator is itself over 1. Change this division to multiplication, take this and flip it over. So you'll have ab over b minus a. b minus a. All right? Now, what do we want to do? We say, well, we try to cross simplify, right? Like we did here. See, in this case, it canceled immediately. Boom, we had the answer. Now, I know what you're thinking. You're thinking, haha, this will cancel with this, but you got to be careful. See, this was an exact identical bullseye match. That's why we could cancel it, but this is not the same. A minus b is not the same as b minus a. So we can't really cancel it. Well, we can't really cancel it the way it's written on the board. It turns out we can manipulate it in such a way that we can cancel it, but we can't cancel it as it is written here. So in order to proceed, let's just continue on and kind of just continue on as if we cannot cancel it, because basically we can't. So there's an implied parentheses here. There's an implied parentheses here. So what would we get for the final answer? It would be this times this. So the way we will write that is ab in front multiplied by a minus b. We're just having multiplied. That's the numerator of the final fraction, multiply. Because remember, when you have a fraction times a fraction, you multiply the tops, and then you multiply the bottoms. The multiplying of the bottoms is just going to be b minus a. So you could circle this on your test, and honestly, I would give you most credit. But it's just too tempting. When you see something this close, you know, a minus b, b minus a, it turns out you can very easily make them match. You have to factor something out. And I'm just going to do it, and then I'm going to show you. You'll understand why it works. It's easier to show you than to tell you. So the top will be the same, ab times a minus b. On the bottom, I can make this thing match a minus b by factoring out a negative 1. And you'll see why. If I factor out a negative 1 from here, what has to be on the inside? Well, I have a positive b, so that will have to be a negative b. I have a negative a here, so this will have to be a positive a here. Now, if that doesn't make sense to you, think about it. Go back and multiply. This times the negative b gives me positive b. This times the positive a gives me negative a. So this denominator, even though it looks crazy, is exactly the same as this. Factoring out a negative 1 is not something you normally do. It's not something we ever just say, oh, I think I'm going to factor out a negative 1 today. But over time, you'll learn that when you factor out a negative 1, it allows you to flip the order around, because what you will have in the numerator is ab times a minus b. In the denominator, you're still going to have this negative 1, but see what happens here? You have negative b plus a. I can flip it around to a minus b. Right? This is like negative 3 plus 2 can be written as 2 minus 3, right? Now you have a direct match, a minus b, a minus b. So let me switch colors. You have a direct match. This term completely cancels this one, but you see the expression is different. You have ab divided by a negative 1. Anything divided by negative 1 just makes it negative. So the answer is negative a times b. That's the final answer, negative a times b. This is a tricky one, because when you get down to this step, you think you're done, you can't go any further. I guess it's something that you just put in your tool bag and you just learn over time, that if you want to cancel something and they look exactly the same, it's just that one, it's a minus b and b, or a minus b and b minus a. They look exactly the same, but the variables are just flipped around. You can always make them match by just factoring out a negative 1. Then you can flip the order of things to make them match. But then when you do that, this negative 1, it's been pulled out, so then it has to be into your final answer there. This is a very good intermediate level problem. Now I have one more I want to do before we wrap up this lesson. I would call this intermediate leaning towards difficult, right? How do we do it? It's going to be as follows. U to the negative 2 power minus v to the negative 2 power, all divided by u to the negative 1 power minus v to the negative 1 power. So again, students see stuff like this and they start trying to factor things out, cancel exponents and things without thinking about doing the most obvious thing. These negative exponents should be written as fractions. So the numerator will have 1 over u squared. That's what this is, right? The minus sign comes along for the ride. This is written as a new fraction, 1 over v squared. Right? So make sure you understand that. That comes from what a negative exponent is. This whole thing is divided by this junk on the bottom, which has its own negative exponent. So this becomes 1 over u to the first power, so I'll leave the 1 off. Minus sign, and then you have 1 over v, again to the first power, because it becomes positive. I can leave it off since it's a first power. Now again, students will try to start canceling things. You cannot cancel things in algebra unless you have terms multiplied together on the top and multiplied together on the bottom. Then you can cancel them, because they divide away. Here you have these big subtractions in the middle, so you can't cancel anything yet. But you can find a common denominator to do this subtraction, and you can find a common denominator to do this subtraction. So how do we do that? Let's set it up. What we'll have is 1 over u squared. I will leave myself some room. 1 over v squared. I will leave myself some room. And then I have the large fraction. And then I'll have 1 over u. I'll leave myself some room here, minus 1 over v. So again, I can multiply a fraction by anything I want as long as I do it to the top and the bottom. Let's work in the bottom first. I have a u and a v. There's really not much in common there, but I know that if I take this one and multiply by this, multiply by v, I have to do it to the top as well, then the denominator will be u times v. And if I take this one and multiply by u, then I have to do that same thing to the top. The denominator will be u times v. It's an ugly denominator, I agree, but it's the same thing, so at least I can then subtract. And then I can do the same thing here. I have a u squared and a v squared, so I'll just take this one and multiply by the v squared from over there, the v squared from over there, and I'll take this one and multiply by the u squared from over here. This is going to be something you see a lot. That's why I'm kind of showing you. So this denominator will be u squared times v squared. This denominator will be, it's written as v squared times u squared, but you can mentally flip that around. It's the same thing, u squared times v squared. So we rewrite everything before we do anything else. On the top, we have v squared over u squared v squared minus u squared over u squared v squared. Again, it's written as v squared u squared. I can flip that around because it's multiplied. On the bottom, I have a v over u times v minus, I have a u. It's written as v times u. I can flip that around to u times v. So this is a common denominator. This is a common denominator. So what do I have in the numerator? In the numerator, I'm going to have v squared minus u squared, v squared minus u squared. That's the subtraction. The common denominator just comes for the ride, u squared times v squared. Then I have to divide that by, ugly fraction coming, v minus u, this denominator is u times v. Now I know that this looks ugly, but it actually is a lot better looking than this stuff, because now I have a fraction divided by a fraction. This is like, I know it's ugly, it's got all kinds of exponents, but you can think of it as 3/4 divided by 5/10. You just change the division of the fractions to multiplication, flip the bottom one upside down, change it to multiplication. So we're going to do exactly the same thing. What we will have, let me switch colors to kind of break things up a little bit. This numerator will just stay exactly as it is, v squared minus u squared over u squared times v squared. Change this fraction division to multiplication. Take the bottom one, flip it upside down. So I will have u times v over v minus u. v minus u. v minus u. All right? So then I say, what am I going to do? Well, again, as I told you a long time ago, right? You can do the multiplication of the fractions you get and then simplify, or you can try to cross simplify first. This is starting to get into what I told you. I said you're going to want to cross simplify first. This is a good example. Sure, you could multiply this times the uv and this times the this, and you simplify all that. Or you can say, well, wait a minute, I have a u squared, v squared, and a u times the v. So one of these u's can cancel with only one of those u's, leaving one behind. One of these v's can be canceled with one of these v's, leaving only one of those behind, right? The way you think about it is u divided by u is 1. This divided by u just leaves 1 left over, and the same thing for the v. Okay? So then what you would be left with on the top, let's go down here. On the top, this is basically gone, divided away to 1, so you'll have v squared minus u squared on the top. On the bottom, you'll still have a u times v, u to the first power, v to the first power, because I struck through only the exponents. And then I will have v minus u. v minus u. And then you say, well, I'm done. I'll go ahead and circle that because I can't cancel anything. But then you remember, It's been about 35,000 times throughout this course, I taught you to always be on the lookout for the difference of two squares. Here I have the difference of two squares. So it should be a reflex by now. V squared minus u squared can be written as v minus u times v plus u. That's what this is equal to. On the bottom, I'll have u times v minus u. Notice what I have is I have a v minus u on the top and a v minus u on the bottom, which can then cancel. That's gone. So then on the top, I have v plus u over u times v. V plus u divided by u times v. That's the final answer. I can't go any farther with that. So if I had started this lesson and said, hey guys, we're going to do something called complex fractions. Here's your first problem. It would be like a nightmare because most people, even if you learn these skills all the way up until now, you haven't seen them all put together. You haven't seen them like, hey, when I have these negative exponents, write them as fractions. Hey, here's how to find common denominators of weird, crazy looking fractions. Hey, here's how to subtract them after I get the common denominators. Hey, here's what I do when I have giant fraction division. I just do the same thing as numbers and change it to multiplication, flip it over, and then cross cancel, and then multiply, and then I'm factoring this into the difference of two squares, right? And then I'm canceling, and then I'm finding the final answer. So that's why we start way back here. We start back here with something everybody understands, and we increase the complexity very, very slowly. So I want you to grab a piece of paper. I want you to do this lesson again and write down all of these problems as the lesson plays and solve them yourself. Just because you watch me really means nothing. You have to practice it yourself. And then we have two more lessons in complex fractions because, believe it or not, as complex as this looks, we actually have some much more complicated problems. But the bedrock is now laid. You understand how to attack it. Now we're going to apply this stuff to slowly and gradually more and more complicated problems in complex fractions and algebra.